Okay, now we'll discuss about how the routing works. Since I have a machine A and it would like to communicate with some machine C. If you say this one is my host machine, yeah, this one is my machine, and this is my machine. Okay, let me take it. Yes. Okay, this is my machine. From here, I'm trying to connect, say, Google or some website, or I just want to some other computer, other part of the world. So that is this. Okay. Say it can be example. You can say it as a Google web server. Okay, or any web server. Okay, so you have a host machine, and you would like to communicate with host C, means other machine where you would like to communicate with and get some response back to it. Okay, so how the machine A sends its request over the internet and reaches to C, that is what we are going to learn. Okay, we know that it'll be going through internet, but what are the main um, uh, parts of our what do you say payload that says that, oh, you have to go here, oh, you have to go here, this is my next stop, oh, this the system is present in somewhere in the internet, so you have to go to the next stop. So how you are going to get to know about that? For that purpose, every systems will have their own identification numbers. As I said, there are two parts of identification. One is the physical address, that is the MAC address. If you see each and every machine in this particular topology, what I have given right from host A to C, every machine has got its own MAC address. This is a MAC address AAA for A. And for router, it has got MAC address as A1. And for uh, like exit port of A, this is the entry port of the router. Okay, and this is exit port, and it is kind of having 6661, and it goes to the internet and travels through so many routers. But all those routers I have not mentioned. You might be having some 10 to 15 routers. It has to go to just to reach google.com, whatever. If you are just trying to enter www.google.com, when you enter that in your browser URL, it might be traveling in such a way that it goes to your home network. From there it exits, and from there it reaches the internet, and then after that it reaches the service providers, uh, like your Google's service provider, whoever it is. It can be, if it is somewhere in US, in the sense like it can be AT&T or T-Mobile or some service providers, their internet. It will reach there as an entry point. From there, it will get into their network, and there it is hosted somewhere in a web server. Okay, that's IP address is this. Our source IP is this one. This is called as source IP address, from where the request it is going to start, and this is called as where we would like to go, destination IP address. Okay, a similar way you have something called as MAC address. This is source MAC, and this is the destination MAC. Okay, but okay, there is some specific thing happens in the background called as DNS. As soon as when you, and from here machine, from this machine, as soon as when you enter www.google.com, okay, your machine will communicate with your router and your ISP, and will get some IP address like this. 7.7.7.7 is the IP address where you have to go. Okay, because over the network the domains are not used, it's mostly the IP addresses. So you're requesting, before you start reaching host, first you have to get to know what is www.google.com's IP address. For that, what you do, DNS query. From your host you'll make a DNS query. Consider you got some response back from your ISP saying that the Google's servers IP address is 7.7.7, just in case an example I'm taking. Okay, so now what happens here is like the host has to communicate with host A has to communicate with host C. It knows the IP address. Okay, it knows the IP address of the source, I mean of the destination. So you know the source IP address, you know the destination IP address. Do you know the MAC address of the destination? You know your own MAC address, source MAC address. Do you know the destination MAC address? Absolutely, you don't have any idea what is a MAC address, because all Google or Yahoo, if you take Amazon, Flipkart, or if you take Airbnb, any websites, okay, they are designated with some logical address called as IP address. These IP address like www.google.com is the domain name, and it will have some IP address. That is example I'm giving 7.7.7.7. Yahoo example I'm taking. Okay, yahoo.com. Its IP address is 8.8.8.8. Getting what I'm bringing out here? So you are trying, like, it is every domain is linked with an IP address. This is for this is like every domain will have an IP address. Definitely there will be an IP address, every domain throughout the world. Okay, the domain will have an IP address. Okay, that it will get updated with our DNS servers at our service provider. Okay, a small copy of frequently used DNS will be stored in our host machines as well, like frequently used, so that immediately every time it doesn't require for you to go and connect to the service provider. Frequently used like Google, Yahoo, all those things you might be sometime before whichever you have used, they might have got already available in your machine because you already use them. So it will refer to that. Okay, so that now, is it possible for the destination MAC address to be known at host by or anyone like your service provider? No chance. There is no chance. What I do is I might have upgraded my machine, even if someone knows it. Okay, maybe like every 1 hour I might be changing from one machine to another. One time I'll be putting in this machine, and next time I'll be putting in another machine. But my IP address remains the same to reach this google.com, but the machine's hardwares might be getting changed. Okay, just remember that. So that is the reason it's very difficult to have the destination, means hosty MAC address over here. So there should be something to make anything like your data to move from one point to another point. These four are mandatory. These four are mandatory, 100%. Why you need source? Means like it has to know that from where the request has received. If some data comes over here, from where it has received is required. So that is the reason you must include source IP. And why you need destination? To move from, okay, to move your data, whatever you're requesting, to route it through the internet. Okay, you need an IP address, destination IP address, so that based on your destination they determine the path which you have to take. Okay, so destination IP is must. We have the destination IP. After doing some DNS query we got it. Okay, but source MAC address I know because this is my machine's MAC address only, so I'll keep it. Okay, and I need destination MAC address. Do I have it? No, you don't. And you won't be having the Google MAC address. And even if you hold it, it's merely waste of it, because it will be going to change. As I said, when you move your machine from one location to another location, okay, the machine, whatever it used to store google.com now might be storing gmail.com. Now might be storing some Google Drive.com. Okay, might be storing, say for example, 10, like it's if it is a cloud service provider, it's getting changed. Now you are actually using a server which is like 1 GB, and after some time, what you have done is you moved your data to high capacity servers, say for example 10 GB. So your hardware got changed. Now along with that, your MAC address will get changed. So holding the destination MAC address in your request destination means like where it is actually the IP address where it is like 7.7.7 in this particular example. Okay, that machine's MAC address keeping it over here is not worth, first of all, not worth. So what is the solution now? Okay, so for that only we have something called as like to know, okay, what is my next hop, because I don't know the MAC address, because I have to destination MAC address. If I don't know means I'm saying about destination MAC address. So to move like to the next hop, we have something called as MAC address, right? Okay, we use MAC address. Okay, so first where you have to go to from your machine to your router first. Okay, for that what you'll include is you have to include destination MAC address as your router MAC address. Means this machine's MAC address. This machine. This entrance will have one MAC address. Exit will have MAC address. But we are including where we have connected. This is our destination. From here, this is the source, and this is our destination. This destination's MAC address you are going to include here. Means this port. It might have multiple ports. Okay. Okay, this might have multiple ports. Here is one, here is one, there might be another one more network over here, another one more network here, but forget about all those things. But what I want is it comes over here and then it sends here, okay, to the internet. Okay, now, so now I want, consider, do I have any destination MAC address? Now I know it. No, I don't know. Consider this is the very first time you are just building the packet. Okay, you just powered on your machine, you know the source IP address, you know the destination IP address, and you have to include source MAC, you include it, and you have to include destination MAC. That is this particular machine's MAC address, correct? Machine means router, okay? This MAC address, okay? How you have come to know about that MAC? That is how, because of ARP, address resolution protocol. Okay, using the address resolution protocol, you'll come to know about the ARP. Okay, using ARP, you'll be able to get to know about uh, the next hop's MAC address. Let us see with one example in a stepwise manner. Okay, so that it will be more clear for you. Let's start. So what I do is, as soon as I power on my machine any given point of time, okay, it is something configured in my device that the default gateway means default gateway is this particular thing. The port, all your incoming and outgoing traffic from and to will be through this particular port. This is called as default gateway. This particular port information is configured. You know about that particular port, default gateway port. Okay, this one. Okay, you know about that. Okay, as soon as when you power on, this is configured in your machine. So that is the reason, as soon when you power on, okay, and when you try to connect to the internet, okay, first you'll say, hey boss, who is 5.5.5.1, I would like to communicate with him. Okay, then it replies saying that yes, I am 5.5.1, and this is my MAC address. This is my MAC address. It will be replayed. I would like to communicate with 5.5.5.1. I would like to communicate with them. Okay, I am the 5.5.1, and you can actually communicate me over here with this MAC address. Okay, so now you have come to know about, okay, the MAC. And one more important point here, I'm just mentioning these MAC addresses, whatever I have shown it over here for the reference. Okay, all these MAC addresses are for reference. These are not the actual MAC addresses. The actual MAC addresses are of 6 byte length. Okay, just in case if you are getting confused, don't worry about that. So this will have one IP and MAC. This will also have one IP and MAC, and you'll have so many routers. As I said earlier, those routers we are not considering. Okay, it can go, it can take whichever way it want, but the packet will go through internet and reaches the other service provider where the Google or someone is connected. Okay, so now, okay, control Y. Yes. Okay. I just raised a request that I would like to communicate, because first you have to know, to move to the next hop, you should know the default gateway's MAC address. So that is the reason you are trying to send a request called as ARP request 5.5.1, and you get a ARP reply with the default gateway IP address mapping with their MAC address. This is the MAC address. This is the MAC address. Okay. So now you got the MAC address. Now what will be the next step? Now what information I have is the first step. Do I know the source IP? Yes, absolutely. I have the source IP. Okay. Do I have destination IP? Yes, I do DNS query and I'll get the destination IP address. This is the destination IP. I have that as well. Okay. Do you have source MAC? Yes, I do have the source MAC address. This is my source MAC address. I do have. Okay. Source MAC. Okay. Do you have? Do I have destination MAC? Yes. Where I have to go to the next hop, I know that. That is my destination. I have it. My default gateway's MAC address is my destination MAC address. I have it because after getting the ARP reply, I know what is my destination MAC address. Because always remember, I was repeating this point again and again. MAC address is used for determining the next hop. To move to the next hop, you need to have the MAC address. Okay. To determine the path, you need to have the IP address. I have where I have to go. It is 7.7.7. Okay. And for that, I need to have the destination IP address. I have it now. And I have to go to the next hop. For that, I have the MAC address of the ARP. Just remember that. Now, if you consolidate it, it looks something like this. Now, you know the source IP address and you know the destination IP address. You know what is your source MAC, and this is what your destination MAC. That is the next hop MAC. Okay. Now, this information, whatever you're trying to send, requires all these 4 fields. Now you are sending your information to the next hop, that is the router 1, and it comes over here from host A to the router 1. Now router 1 received the data, okay, with all this information. Now it has to determine where is 7.7.7. Okay, that is what it is. It has to do. It has to determine the path, because the ultimate destination is like 7.7.7. So what it does, first it will check the same way, like whether it is connected to within like 7.7. Anywhere within its routers. Okay, so no, because if you see the networks, what it is connected is 5.5.5 and 6.6.6. Correct, right? 5.5 is the router, I mean like this particular network, and this is like connected to 6.6. So this router is nowhere connected to 7.7.7. So now what it does, that's a more interesting thing what you have to learn. Now router 2 has actually received the uh, packet. Sorry, router 1 has received the packet. Now it has to determine how to reach 7.7.7. Since it has not having this particular thing, now it will look into its routing table. What it will be there in the routing table? Okay, how to reach network 7 is available. Like routing table will have the information something like this. A small table in every router that, okay, router and its gateway IP. Router, gateway. If it is connected to 10 routers, all routers IP address and router names will be here. Like this it will be. Okay. So this is how it is determines. IP table will have the information, just logical I'm giving. It won't be something exactly like this, but to understand in a basic level, router will keep track of like to how many networks it got connected. Their IP addresses will be available in the routing table. Now it has come to know that to reach 7.7.7, it has to communicate with router 2. It has determined. But how to reach router 2? That means it has to use the MAC address. Does it have? It'll come to know that it doesn't have it. So what it has to do? Again, it has to ARP. The same thing what we have done it earlier to determine the gateway's MAC address. The same way router 2's MAC address, we have to determine. How you are going to determine it? By sending the ARP request. But to tell you frankly, uh, the routers in the internet, they'll be communicating all the time because you are not only one person. There are like so many people trying to reach Google. So they will keep track of all the uh, what do you say MAC addresses of their adjacent routers. Means like if this is a router, if it is connected to multiple routers, all these routers MAC address is actually getting stored in some location in the router called as ARP cache. If it is not there, then definitely it does what? ARP request. But we will be concerned because we already discussed about the ARP request and reply. Now we'd like to know what is ARP cache. That is the reason I have given. So consider that you know the destination MAC address. I mean the router to MAC address. So how you will come to know, because it is available in ARP cache of router 1. You know what is the next hop MAC address. You have already determined it because it is already in your cache memory of your router. Okay. So to reach the next router, you need to have the MAC address, right? So that is available in your ARP cache, router 1 ARP cache. With this information, now you can build new set of addresses, correct, right? What is the source? What is the destination? What is the source MAC and what is the destination MAC? Okay, so that particular information, now you're going to build it again. Now we know the MAC address of the next hop, that is B2, this particular ports. Okay, router 2's this port, this particular port. Yeah, this one. Okay, so we know that. So we know we have the source IP and we have the destination IP, and we know the source MAC address, that is B1. Okay, from here it is starting, right? That particular MAC address you will be keeping it, and the destination MAC address is this one, B2. Okay, and you'll be sending it over to the router 2. And now router 2 receives that particular information. Now once it receives the packet from the router 1, the router 2 has to determine where exactly the destination 7.7.7 is present. Okay, now first it will check whether it is belongs to its own network. Yes, I am connected to 7.7.7 itself, so I have direct connection with him, so I have all the information that is required now. So now see how the router 2 sends with all information to host C, that is 7.7.7. But this is belongs to the router 2, because 7.7.7.1 means all 7.7.1 or 7.7.2, 7.7.3 or 6, 7, 8, 9, 10, all like are connected to this port. But I would like to know which host is really, what do you say, is having this particular uh, like IP address. For that, what I'll do, I do from as a machine from a router side, I do have to know the MAC address of this particular machine. So for that, I do ARP request. Okay, that is ARP request. So to know the MAC address of the host C, what it does is router 2 sends ARP request to host, I mean like to all the machines which are connected to router 2. In them, host C that replies that, oh, I am 7.7.7. This is my MAC address, that is CC. Okay, then it received. Now router 2 has got what is the source IP address, what is the destination IP address, and also what is the source MAC, and as what is the destination MAC. Now I have all the information required. Remember this, ARP request happens only the time when the router 2 doesn't have any information about what is the MAC address of 7.7.7. If in case, if ARP cache of router 2 is having the MAC address of I mean like host C, then it doesn't perform any ARP request. It will directly send because it already know the MAC address of 7.7.7 is CC. Just remember till that extent. If you observe it carefully, the data that is started, like when you are trying to the path, when it is trying to reach from host A to host C, one clear observation you can make it out that everywhere the source and destination IP addresses are the same. There is nothing got changed. Only the MAC addresses are continuously getting changed till it reaches the destination. If you see that at the beginning, the MAC address of the source is AA, and to reach A1, they have kept it as A1. Okay, but now in between, to reach from this particular router, okay, to reach router 2, the router 1, what it does, it replaces the MAC address of this particular thing as source, and it will keep the destination as B2. Okay, this one. Okay, and forward it to the next hop. And after it receives it, what it does is it will check. Okay, the source and IP address, it's not going to modify. Only the thing is I have to go to the next hop. What it does, it will remove the whatever the B1 in place of it as C2 as source, and it has to go to the destination to CC. So it will replace the destination as here, okay, as CC, and then it's forwarded to the MAC. Once the MAC it receives, it opens up. First, it will check the destination packet of MAC, I mean, destination address of the MAC. Oh, does it belongs to me first of all? Okay, yes. The destination MAC is CC. Yes, it belongs to me. Then I'll check what is the IP address of whether it belongs to me or not. Okay, but it doesn't check the source MAC address because whether it belongs to it or not, that it has to check first. Okay, now the MAC address, it is satisfied that rule whether it belongs to it or not. Now it will open the IP packet and will check. Okay, the IP address, the destination IP address, Does belongs to me or not? That is 7.7.7. Yes, it belongs to me. Then what it does, then it will give to the above layers, like all other, like we'll see about them, what are all other layers in later point of time, like application layer, presentation layer, all the layers. But now it has come to know, yes, this packet whatever I have received is belongs to me, it doesn't belongs to anyone. Okay, so I have every right to open this and serve that request. So it follows the same path back again. What it does is, in the source IP address, it puts IP address of 7.7 when it is responding back, and destination as 5.5.5 because it is received from source, whichever it is received, right? So it'll put source as 5.5. I mean destination as 5.5.5, and source as 7.7.7, and puts the MAC address as uh, source MAC as CC and destination MAC as C2, and sends it to the next hop. From there, it traverses same, doing all the MAC changes, but without changing the source and destination MAC, and reaches to the host A, and you'll see your Google page. This is how it works. The routing works. Okay. Remember what is happening to determine the next MAC address. If you doesn't know, then you have to do ARP. But first you have to check it in your systems or the router's ARP cache to see whether the IP address trying to reach or the gateway is trying to reach, its MAC address is available with you or not. If it is not there, then you have to use the ARP request and you'll get the ARP response reply. That is called the responses ARP reply. Okay, so this is like how your routing works.